right, this is going to be a warm-up to get you ready before you start your test review. The test review is a separate video. If, as you're working on your test review, you need help, you should refer to that review. This video will just cover these 4 problems. So if you don't have a packet, go ahead and take a screenshot of this because I'm going to separate it out. Okay. So we are first asked to divide f of x by x minus 1. I'm going to use the box method. If I need to divide again, I will use long division. So we have x minus 1, and we're dividing into x cubed, 2x squared, negative 11x, negative 12. Now the x cubed is going to immediately go into the top left box. X cubed divided by x is x squared. Then I multiply back. X squared times negative 1 becomes negative x squared. Now I'm going to subtract. 2 minus negative 1 becomes 3. Now I'm going to start the process all over again. 3x squared divided by x becomes 3x. 3x times negative 1 is negative 3x. Negative 11 minus negative 3 becomes negative 8x. Negative 8x divided by x is negative 8. And then negative 8 times negative 1 is 8. And I find here that I do have a remainder, and that remainder is negative 20. So based on my answer, so if I were to write this out, my quotient would be x squared plus 3x minus 8 plus negative 20 over x minus 1. Based on my answer to part A, what is the relationship? So the answer to B is x minus 1 is not a factor. It does not divide in evenly, therefore it is not a factor. Letter C, evaluate f of 1. Well, here I'm going to use the remainder theorem. Remember, if something divides in evenly, it has a remainder of 0. Like if it said f of 1 equal, if I was told f of 1 equaled 0, that means there's no remainder and it is a factor. But in this situation, I have a remainder of negative 20. And what that means is f of 1 equals negative 20 by the remainder theorem. Number 2 says write a polynomial function in factored and standard form that has leading coefficient of 1, and then has zeros, negative 1, 1, negative 4, and 2i. So it's important to note that complex solutions such as 2i, complex solutions containing i, must come in conjugate pairs. So here we really have plus or minus 2i. So we've got f of x equals 1. A 0 of 1 means a factor of x minus 1. A 0 of negative 4 means a factor of x plus 4. And we talked about this on Friday. If we've got zeros, well, that means at some point I took the square root of negative 2, and x squared plus 4 must have been the factor that gave me that. So there is factored form. Now to go to standard form, I need to multiply all 3 of these binomials together. Now I want to remind you that when we multiply 3 things together, like if I was doing 2 times 3 times 4, you don't do 2 times 3 is 6, and then 2 times 4 is 8, and then multiply 6 and 8. You would do 2 times 3 is 6, and then 6 times 4 is 24. We're going to apply the same multiplication principle here. First, we're going to do x plus 1 times x plus 4. And then multiply the result times x squared plus 4. It is 100% incorrect to distribute, I put that in air quotes, the x plus 1 to both binomials. Like you wouldn't do 2 times 3 and 2 times 4 and then multiply that together. Don't do it here either. Here we go. So I get x squared plus 4x minus 1x minus 4, and then I put those together and I get x squared plus 3x minus 4. And now I need to multiply that times x squared plus 4. So there are lots of different ways to multiply this. I'm just going to distribute. So first I'm going to distribute the x squared. So I get x to the 4th plus 3x cubed minus 4x squared. Then I'm going to distribute the 4, and I get 4x squared plus 12x minus 16. These terms cancel, and my standard form will be x to the 4th plus 3x cubed plus 12x minus 16. Oh, that's ugly. Okay. Number 3 says solve for all solutions and to do it using the most efficient method. So let's take a look. Letter A, I'm going to start by taking out the x. And I've got x cubed minus 8. Then I'm going to factor x cubed minus 8 using difference of squares. So what's being cubed? Square the first, multiply them together, square the last, and my signs are same, opposite, always positive. So now it's not going to factor anymore. I'm going to set everything equal to 0, and I have 3 factors I need to work with here. So I've got x equals 0. That's done. Obviously, x minus 2 equals 0 is going to be x equals 2. Then I have this trickster, x squared plus 2x plus 4. I can't factor it, but it is a good candidate to complete the square because a is 1 and b is even. So I'm going to move the 4 over, leave a little space. I'm going to take my b value of 2, divide it by 2, and square it. This allows me to create a perfect square trinomial that factors to x plus 1 squared. Now I'm going to take the square root of both sides, and I get plus or minus I root 3, and I'm going to subtract the 1 as my final step. And so my other 2 solutions here are -1 plus or minus I root 3. For letter B, I notice that there is a greatest common factor. So I'm going to take that out. I can divide everything here by 2x, and that leaves me with x to the 4th minus 13x plus 36. Ooh, this was supposed to be squared. Ooh, and that's really ugly. Okay, so now I can think to myself, in parentheses, we have a trinomial. It starts with a 1, and my powers are 4 and 2, which means it can be factored. What adds to -13 and multiplies to 36? 4 and 9. So I've got x squared minus 4, x squared minus 9. Now you have a choice. You can continue factoring using difference of 2 squares. Make it x plus 2, x minus 2, x plus 3, x minus 3. It's up to you. Or you can go straight to the zero product property. Here, I'm going to divide both sides by 2. I get x equals 0. Here, I'm going to add 4 to both sides and take the square root. I'm going to add 9 to both sides and take the square root. So there are my 5 solutions for number 3B. Finally, letter C, there's no greatest common factor, and it's a trinomial. So the first thing I'm going to do is multiply 5 times -12, and I get -60. And I think to myself, is there anything that multiplies to -60 that adds to 17? So it's going to take me a minute, but I'm going to think, all right, well, 1 and 60, no. 2 and 30, no. 3 and 20, 3 and 20. And the 20 needs to be negative. Yesterday, I did a problem like this using split the middle, and so today I'm going to use the box method. So if I use the box method to factor this, in the top left box goes 5x squared. Then I'm going to put the 3x and the negative 20x and then the negative 12. Remember, the negative 17 is represented by 3 minus 20. I'm going to work with this 3x first. I know the 3 can't go on the side here because of the 5, but this could be an x and this could be a 3. Well, if this is x and this is 5x squared, up top needs to be 5x. If this is negative 20, then this is going to need to be a negative 4. And sure enough, negative 4 times 3 is negative 12. So I see my factors are x minus 4, 5x plus 3, which gives me two solutions of 4 and 3/5, negative 3/5. All right. And then the last one is asking us to sketch a graph from factored form. So I see I have degree of 1, 4, 5, 6, 7. And what is the multiplicity of each 0? Well, I have 0, and that's a single, or 1. I have 3, and that's a triple, or 3. I have negative 1, which is a double, or 2. And I have 5, which is also a single. So now I'm going to go ahead and make my XY axis, and I'm going to scale it off really nicely because, you know, we are good mathematicians and we attend to precision. All right. So I've got 1, 2, 3, 4, 5. There's my single. I got a triple here at 3. I've got a double at negative 1. And I've got a single at 0. And because the degree is 7, I know, and my leading coefficient is positive, I know my end behavior looks like this. So I'm going to start, let's start with negative 1 as the double. And I want to remember that 3 is a triple. So negative 1 is the double. It's going to come up. And I know this is going to be a straight cut through 0 because 0 is a single. Now it's going to need to come down, and I need to have a change in concavity here. So I'm going to draw that first, like that, and then like that. And then I'm just going to swing this guy up. I'm going to connect these. That looks pretty good. That could be a little straighter at 0. Like I might want to get that like a little more straight. But that's pretty good. Let's see. Did I do these in different ways? Oh, so here I split the middle for C if you need it. Just as a reminder, we have our quest on Thursday, Friday, depending on if you're an A day or a B day. You have no homework to submit. The review video is in the module. I will probably have also sent it to you on Remind. You, for the rest of the period, are to work on that review. Here is the new schedule if you still need it. And just some other information. Thursday, Friday's test, in past years, this is typically the most challenging summative test we take in the building. It is very common for students who are not adequately prepared to run out of time. You need to be efficient and confident in your work. If you have not had adequate practice towards proficiency, you will run out of time. If this happens and your test submits automatically because you have run out of time, you are to finish writing the exact thought in your head and email me your file immediately. At this point, you are to go work on the review. It is available in the module, and the video is also available in the module.